Altium software. So, starting with the presentation, I'll be covering at first installation and licensing part. So, how do we install, download and install the Altium software from its website? Then how do we activate the license and troubleshooting if there are some problems with it? So now how to download? So I'll show you how we can download the Altium software. So you can directly search Altium Altium Designer on your browser, and you can go to the first link, which is altium.com. So this is the Altium official website. So to download the software, you will at first have to register on the website along with your institution login ID, credentials with your institution mail ID. And within that, you can go to research and support, and in the download section, you can find your multiple software which are provided by Altium. There is Circuit Maker, Circuit Studio, Infrastructure Server, MCAT Designer. But in this workshop, we will be using Altium Designer, which is the first one. So after registration with your institution mail IDs, you can install the online installer from this website. I'll show you how do we do it. So the installer is being installed. So after downloading the installer, we can just follow the procedure. Yes, we can just follow the procedure, and we can select the directory where we have to save the software and just follow the installation wizard for the installation. So the download is complete. Now I'll show you how do we install the Altium software. So just allow all the permissions which it asks for. And this is how it will installer will look. Just go next, accept the agreement, go ahead. Then there are like two different options: the new installation and update the existing version. So I already have Altium installed on my space, so it is asking me to update, or I can also do the new installation. To the next, after which it will ask for signing in. So the once you go to the Altium website for downloading, you will have to register with your institution mail ID, and after with the same institution ID, you can sign in over there. So after clicking on signing in, it shows that I have successfully signed in, and it shows what are the things which I can download. You can currently I'm downloading platform extensions and importer and exporters. What is in the platform extension? There are multiple extensions provided by Altium. And by default, it is installing the PCB design, where we can design schematic, 3D modules, and other things. And there is also the third, which is importer and exporter. By installing this, we can convert any PCB file from one software to another. For example, if I have designed a PCB in Eagle software, so by installing this importer and exporter, I can import the Eagle file into the Altium file. Similarly, we can do that for different softwares. So there are multiple software such as Nsoft, Hyperlinks, Allegro, then KiCad, OrCAD, Eagle, and other more. After this, we can just go to the next. We can change the directory if we want. If not, we can keep it default. Then there are some workshops conducted by Altium as well. So if you want to get notified, you can click on yes, I want to participate. If not, then you can just simply click on don't participate. And then next. And after next, it will start the installation process. So for installing, it can take some time. But I already have installed, so I'll directly switch over to that. So that's how you can download and install. So that was the first step of installing the Altium software. Now the next step is license activation. So once you install the Altium software, this is how your the software will look like. But in that, when you install, there won't be these two licenses visible. which is Altium Designer Professional, and Power Analyzer by Keyset. There would be only one license available, that is Altium Designer Viewer. But to draw the schematics, you will need Altium Designer Professional. For example, if I release this license, which it means that I'm currently not using any of the license. So if I try to create a new project right now, it won't allow me to create a new project. For that, I will need this Altium Designer Professional. If I use this license and then I go to file and create a new project, it will allow me to create a project. For that, for creating new projects, you will need this Altium Designer Professional license. So how do you get this license? So, so these are the steps which I have mentioned in my presentation. I'll just go through this. So at first, you will have to visit the same Altium's website. There, under the training and education section, you will find this university, educator, and students, where they're giving academic licenses, training, sponsorship, and certificate for higher education. So once you go there, this is how it will looks like. So in this, you have to go under the student programs section. So once you go over there, this home page will appear. So in this case, you have to enroll. Just go to the enroll for free. When you click the enroll for free, it will ask you for your institution mail ID and institution name. After that, it will send you a verification code on your mail, and after verification, it will ask your personal details as well as institutional details. So after filling that all the details, it will say thank you and all this, and within the 24 hours or so, your Altium Professional Designer license will be activated. That is what I have mentioned in this next two slides. So I'll just go through the presentation. So at first, you have to visit the Altium website, then navigate to the training and education section, under the university and educator students, you have to enroll under the student program. After which you have to click on enroll for free, and then complete the required details. Then after completing, you submit the form, and these are the details which it will ask, like first name, your last name, mail ID, mobile contact number, university name, and all those things. So, and after completing all this information, within 24 hours, you will receive a mail from Altium stating that your account has been activated. And once your account is activated, you can go and design the PCBs on the Altium software. So once you get your license done, you can see your license on the license and management tab. So just in case if your license and management tab is not visible, for example, just home page is visible on starting the Altium software, you can go under your top right under profile section. Here you can see the multiple tabs. First is profile, then license and extension and update, and custom connections. So under that, you can go to the licenses file. And here you can see all your active licenses, which licenses are active, when will those licenses expire, and you are currently using or not using. So right now I'm using this license. Now talking about some other features. So if you come on the home page, there are multiple things which you can use, which you can refer to. For example, there is a learning center on the home page itself. So this learning center contains multiple videos on designing the PCBs, how we can improve our schematics, PCB, and new upcoming technologies, new upcoming updates on the Altium and all. So you can also go through these videos. These videos are officially uploaded on the Altium YouTube channel as well. You can also go and watch those videos over there. The next thing which I'll explain is basically the UI, we can say, of the Altium software. So the first thing here on the top left we can see is the toolbar. So there are like file section, view, project, window, and help. So I'll explain what each and everything later. After that, there is on the left hand side, you can see the project panel over here, and there is also a navigator. So what does these things do? So during schematic drawing of schematic and PCB designing, we'll cover that. And if you don't want this navigator or projects, you can directly just right click on that and close those sections. And if you want to see the navigator and all, there is one important feature of the Altium, which is on the bottom right. You can see here the panels section. So if you go under panel section, you can see the multiple uh, ta- uh, tabs coming out. Uh, this all this is the like I feel like this is the most important feature of Altium, where we can go and select what are the things which we want to display on our Altium screen and which are the things which we don't want. So if I want to use the navigator, I can just select the navigator, and on the left hand side, the navigator has opened up. This is the project section in which what are your active projects. It will display on the left side. The next important thing that was about menu and toolbar and project panel. So the next important thing in the Altium is workspace. So what is the workspace? So on the top right side, you can see the Sardar Patel Institute of Technology name. So that is my current workspace, which under which I'm working on. If I click over, when you create your new account, there won't be any workspace. It will says no connection, and if you click on there, that will ask you to create a new workspace, or you can join a new workspace, existing workspace. So what does this workspace do? This workspace actually acts as your GitHub repository, basically. On this workspace, you can store all your design on the server, and which you can access later on. It is nothing but just we can see this is the Git repository of the Altium. So if I go to the workspace, this is how it will look like. So under project section, it will show all the projects which I have done, which are being saved on the server and all. Then there are multiple components which I have downloaded and imported. So this is the section. There are some MCAD files. If I have designed, it will be displayed over here. Then this is the workspace member who are currently working on this workspace and all. So just we two are working right now. If you want to see any of the projects which I have done, so there are multiple projects. So I'll just show you one of them. This is the control card project. So this is how its schematic look like. So this is basically a multi-page schematic. You expand here, you can see this 5 files. These are all files are from the same schematic. You can just see the schematic. So anyone who has the access of this workspace can see all the projects which are being done. If he wants to notify me some changes, or for example, this is the connector. If someone has noted that this connector is wrong, this placement is wrong, or the connection is wrong, they can easily send me the problems. What is the problem? For example, they can directly add the comment over here, and they can directly tag me. For example, initial. For example, they can always say that hello Anshul. The connector is wrong, and I can directly post this comment, and it will ask me whether I have to. It will, yeah. So after placing the comment, it will basically mail that person that someone has noted the change which has to be done, and anyone viewing the file can see what are the things they have to update and. So that is the one thing of the workspace, and you can basically store all the files on the workspace. That was of the workspace. Now talking about the shortcuts. So before coming to the shortcuts, I'll directly show you how to first create a new project. So to create a new project, just make sure your Altium Designer Professional license is in use. So we can directly go under File section and New. Here there are multiple options what we have to do. For example, there is if we have to make a new schematic, new PCB file, new output job file, or new library. So just for now, we will just create a project. it will ask where do we have to store. We have to store on local PC, or you have to save on the workspace. At first, I will show you how do we store on the our own PC, and then how do we upload it on the server. So yeah, I'll just store it on local project. Uh, here you can select what do you have want on your project. Currently, I'll just select the empty project and just give it the name test project. Here you can just change its path. Where do you want to save? Right now, I'll just keep it default and then create. So once I create the project, here on the left hand side, the project name will appear. But here you can see there are no documents added. So I can't do anything with this project right now. So for that, for creating the schematic, at first I will have to import a schematic file on that uh, with project. So you can just right click over there and then go to the add new project and then add whatever you want. So at first we will create a schematic. So we'll just add schematic file. So this is the new schematic file. Uh, so the first thing which what you have to do in the while creating the schematic is define the dimension of your schematic file. So how you can do that is go to the directly go to this properties section, and if the property sections are not displayed on the left right hand side of your screen, uh, I'll remove it and show it to you. So right now you can't see anything on my right hand side. So in that case, you can go under panel section and you can just select what are the things you want you will be using actively. So you want it displayed on the screen. So right now I want properties. So you can go under property section. So these all are the parameters which we are displaying right now. These are the grid dimensions. Yeah, the one thing on the Altium software is about the dimension. The default by default, the dimensions setting is on the mils. Here you can see mils. So mils is nothing but one type of unit. But if you want to just switch the unit, you can go to the mm. Or if you don't want to go to properties and change the dimensions, you can directly go to the edit section, sorry, view section, and there is the option of toggle units. You can directly go and toggle units. Right now, you can see on the bottom left, the units is in the mm. If I want to change the units, I can just toggle unit. Right now, the units is in the mils. So that's how you can change the dimensions. Sorry, you can change the unit. Now, talking about the dimension, you can go under properties section. So there is the page options, where three columns are shown. First is the standard. So there are some standard size defined, which are predefined by Altium. For example, A4 size, A3 size. So the by default size of schematic is A4 size. If I want to make it some large, so I can select A3 size. It is much more bigger than that. It is almost double than A4 size. Then if I want to increase, if I want again big schematic, I can directly go to the A0 size. So this is how A0 size schematic will look like. You can always see the site. If you want to change the dimensions, you can just change here. You can see the dimensions are mentioned in millimeters right now. If you don't want to use the standard standard sizes, you can always have your custom size. For example, if I want to have a schematic of, let's say, 200 by 250 That's it. So right now, this is the schematic file, which is of 200 by 250 dimensions. But right, we'll be using just the standard template, which are given by Altium, standard size. So yeah. Then there are some like other parameters like margin and zone. If you want to show, these are all for your own reference. If you want to show the margins and all, it's good. If not, then you can just turn it on and off from this. So this is how your schematic page will look like at first. So so now we have completed the schematic. How do we create the schematic project, or how do we create a new project? But after creating a project, you will have to import all the components which you want to have on your circuit. So how do we import those components? So there are actually two options. You can go under panel section and go to the components and here. If when you go under components, these are all the components which it will display. For example, if I want a capacitor, I can directly search capacitor over here, and these are all the capacitors which are available on the components section. But yeah, so you can directly drag and place the component. But the under this component section, the components which are mentioned are actually generic components. So what do I mean by generic components? So these components have just fixed value. They do not have any footprint. They do not have any package. So after you can create the schematic with this, but after creating a schematic, when you go to the PCB designing, it will create a lots of problem that it will say the footprint is not available or the package is not available. Say, I won't advise you to use the components section to draw the components and all. For those, for that, I'll actually say go to the panel section again, and under the manufacturer part search, here you can see the direct components which are being made from the manufacturer, and Altium has actually gathered all those components from the multiple manufacturer. Then they have created its PCB footprint, its 3D file, and they have uploaded on the Altium cloud. So you can directly access those components under manufacturer part search. For example, if I want a resistor, and in this manufacturer part search, you can be very specific that I want this component of this size and this much current rating, this much tolerance, and it will give you all those components. For example, if I want a register of value 10K, its package should be 0603. So these are all the components which it's displaying. So if I want to see what is the details of the first components which is it is displaying. So here on the bottom you can see the details. So the first one, Yago, is manufacturer, then it is fixed. These are all its properties, that it is a fixed resistor. Point 0.1 watt is its power rating. This is the value of 10K. This is voltage rating. This is the tolerance, that 5% tolerance is that this resistor can have 5% tolerance. It is surface mount. Its package is 0603. And if you scroll below, you will also see its footprint, sorry, the symbol. And as well as here, you can see it's a 2D as well as 3D symbol. So if there is a toggle button over here. So right now, this is the footprint which we can see. And if I want to see its 3D version, I will just directly click on this 3D, and that's it. You can easily see this 3D version. So now coming to the controls. Sorry, I missed the control parts. So how do I control all this? So, uh, so this is the 3D part. So to move this 3D part, actually, I'll just click the right click of my mouse button and just move it along with. So as my cursor moves, the components also move. To rotate this component, I'll just click the shift and then drag it with the mouse by clicking the right button. So right now you can see that I can move this 3D view component as well. And the same goes for the schematic file. If you want to zoom in and zoom out, you can just use control and scroll for zoom in and zoom out. If you want to move from one page, one side of the page to another side, you can directly just click the right click button and you can move from left to right or in whatever direction you want. So that's how you can basically move. You just have to right click and then move to whatever direction you want. Uh, those are the basic features, or we can say basic how we can navigate from one place to another. Now talking about creation of schematics. So I'll just show you one simple circuit. So this is the one circuit which I have drawn on the Altium. I'll show you how we can draw this schematic from the scratch. So this is nothing but a voltage sensing circuit, which is done by using a differential op amp, which is LM2904, 2904, sorry. So while creating a schematic, you just have to keep in mind that you can, as the Rao sir said, you can place component in any order, but just make sure that its connections are done proper in the proper manner. So let's start with the schematic. So the first thing is basically adding the components from the manufacturer part search, or we can say the Altium cloud, to our schematic sheet. So the first component which I'll add is LM2904. I can directly search over there LM2904. Then these are the multiple LM2904 which are available on the Altium cloud, of which are from different manufacturers. For example, the first one is from onsemi, second is from Texas Instrument, then third one is again from onsemi. If you don't want to this small kind of a display, you can just drag it, and here you can have a separate window for manufacturer part search as well. So here you can select which op amp basically you have to use. So right now there are multiple op amps. In the manufacturer part search, you can also see the multiple things which are being displayed over here. So what are those things? So starting with the left hand side over here, the first one is the blue or gray colored symbol, which says this symbol actually means that the Altium cloud has its model available. If, for example, I can go here below and it see its model whether it is available or not. It has both the schematic model as well as the footprint 3D and the 3D model. If the schematic model or footprint model is not available, it will just cross this symbol. For example, if I select the component, so this is the another decoder. Here the symbol is present, but it is crossed by a red mark, which means that this symbol's footprint and model is not available. If you scroll down over here, you can see the symbol is not present as well as the footprint is not present. So I'll always prefer you guys should add the schematics, which you guys should add the symbols whose model is available on the Altium, so that it will help us in the near future whenever we will design the PCB. So right now we'll just add our first component, that is LM2904. Here also you can see the descriptions, the category. Then it also comes with the supply info. These are basically the prices which are fetched from the online distributor like DigiKey and all. If you want to, the Altium also gives you freedom to basically directly navigate to the data sheets and all. So how we can navigate to the data sheet? We can just select whatever component we will be using, then just we go down. Here you can see the data sheets which are available. Here are the different alternatives for the same IC which we can use, and which are in the stocks. If I want to see the data sheet, I can just click on the data sheet and it will open in my browser. So this is the data sheet of LM2904 differential amplifier. Now adding this symbol to the schematic, I will just select it and just drag and drop it onto the schematic sheet. So yeah, this is how I can place the components in the schematic. Just select the component which you want, and then you can just simply drag and drop on the schematic sheet. That's it. I'll just have this window on my left hand side here. That's good. This is the layout basically which I prefer. You guys can have your own custom layout. You can just change whatever things you want to be displayed on the layout and whatnot. So yeah, so that's the LM2904. Yeah. So right now, I'll just show you how do we import and draw all these components over here. So the first one which we have imported is LM2904, which is on the center. Right now we will add its discrete component, which are RLCs, like resistors, capacitors, and all. So the next thing we should add is the 10K resistor. So you can directly go to the manufacturer part search. Here you can search 10K resistor, and these are all the resistors which are available. I'll just select one register whose model is available on the Altium. So yeah, its model is available on the Altium. So if you want, there are the components actually comes with multiple packages. So multiple packages means what? So here you can see it is of this component is of 0603 package. So what does this package mean? The 0603 package actually means that it is of it's the package actually states its size as well as its power rating. So uh, while designing the schematic, you should keep in mind what are the power ratings which I am required, and according to that, you have to select all the components. So I'll just the 0603 works fine for my schematic right now. So I'll just add those components. The CRC W603 is the by default value which is set by Altium. If I don't want this big value, I can just double click and just change the value which I want. So I can just easily write 10K. So yeah, that's how you can change the value. So in the right, if you you can easily copy paste this component by like normal controls, Control C, Control V, and then place the component wherever you want. You can see that the value and designators are currently overlapping. So you can just drag and place wherever you want your designator and the value to be displayed. So yeah, that's that. And you should make your schematic as simple as it can do, so that anyone who is viewing your schematic can actually understand in the simple way what is the schematic, how does it navigate from one place to another, and so that was the register. The next thing we can add is the capacitor, which is a zero point 0.1 microfarad, 25 volts. So I can easily search here, zero point 0.1 microfarad, 25 volt. So, so these are all the capacitors which are available. So if I want of 25 volts, you can directly search here 20 volt. If not, you can just go to the details and see which capacitor is of 25 volt and what's his package. If this package suits fine, I can easily add those component in my schematic. So yeah, one thing after adding the components, you can rotate this component by just clicking by selecting the component and just clicking the space bar. So when I click the space bar, you can see it starts rotating. So, yeah. So right now I want it in this direction. You can also change its designated component value. It is of the value. It's up to you what value you have to give. Right now I'm giving zero point 0.1 microfarad, 25 volts. So it over here. We can also rotate the values as well. This thing is register. Then there is again capacitor. So that this are the RCs. There are again capacitors and resistors over here. Yeah, one thing, if you don't want to copy this component, you can just select the component, click shift, and just drag that component. You can see the component comes along with it. I'll show you what I have done once again. Just select the component which you want. For example, I want this component, but instead of Control C, Control V, there is another alternative. You can just click the Shift button and just select the component and drag it with your own mouse. So you can see the another IC has been popped up. This is nothing but you are copying the component and placing it on some another place. So this is the capacitor. There is 4.7K register. Yeah, 4.7K register. now it looks like I have completed this much part. There is 1.5K and 2.2K register. Now you can see I have just typed 1.5K, but this the components which is showing is different. So the component which you want, you have to be like little more specific, like what I want, like 1.5K what exactly, 1.5K register or 1.5K named another components. So I want register, so I'll be just little more specific. I want 1.5K register. So and another one is 2.2K. I'll just change their values. So it's for 2.2K. Another 4.7 nanofarad capacitor. Hmm. The one thing here you can see there are red lines which are mentioned for the first two components. Yeah, and for the rest of the component there are some green lines. So what is the meaning of this red line and green line? So if you keep your mouse over that and hover over there, it will display what does it mean. It says the life cycle state Altium obsolete, which means that this component is not currently not being manufactured by the manufacturer which is mentioned over here. But it doesn't create any problem because the same components can be manufactured by another manufacturer. So you can see the same component of 4.7 nanofarad, which is manufactured by another manufacturer, and those components are available. You can easily take those components. So it looks like I have completed all. I have yeah, I have imported all the components which were there on the schematic. Now time to make its connection. So how do we make connection? You can go to the toolbars, and here you can select the wire by which you can make the connections. So if you go to the place and click on the wire, you can see the little cross symbol which is aligned with my cursor. So whenever I go near to the any component, it will be highlighted in the red, which means that the component and the wire is being connected. You can just select over there, and you can just drag wherever you want its connection to be made. So I want it to be connected to the pin number 3 of amp. So whenever I go near pin number 3, the cursor again, the mark is again highlighted in red, which means that the connection has been established. But for every time to make the connections, you will have to go to the place and go to the wire. Instead of that, there is a shortcut for a wire, that is Control and W. So whenever I place Control and W, it will just go to the wire, and we can just click with the mouse where do we want to go direct the wires. Right now, again, if I press Control plus W, here you can see you can directly connect the wire. So by this, you can connect all your required components with each other. So all these shortcuts you won't be remembering if you try to learn them. So to remember all the shortcuts, you will basically have to practice it on the Altium. And as you practice, you will basically become the Altium software will become more handy because there are lots of things which you can't be remembering. So whenever you try to use those features, you will have to search them online. For example, if you want to see what are all other shortcuts, you can directly go to your browser and just search over here Altium shortcuts. Altium shortcuts, please. So there is one column in the Altium website only, which is on the official channel for shortcuts. So here you can see what are the shortcuts which can be useful to you. So these are for in this link. Basically, there are multiple shortcuts which can be used. For example, the first one is are the shortcuts for PCB editor. Next one is for PCB schematic editor and all. So right now we are editing the schematic. So schematic editors shortcut can be very useful. So if I want to see them, you can just go there and these many shortcuts are given, which we can use while designing the schematic. So it is not humanly possible to memorize all those things. So as you draw the schematics, you can just it will be basically beneficial for you whenever you draw the schematic and learn the shortcuts along with it. Well, right now we will make just remaining connections. So this is how you can just connect all the components. So right now up till now what have we done? So we have created a schematic project, selected the components from manufacturer part search and imported on the schematic file, schematic sheet, and we, uh, we have placed those components and made the connections up till now. Right now, so next is you can see in the schematic there are multiple power ports. So power ports means what actually? So the 15 plus 15 volt supply, minus 15 volt supply. Here are 3.3 volt supply, the ground. So all these are basically nothing but the power ports. So how can we add those power ports? You can again go to the place and here you can see the section called power port. So if you go over there, when I select that, it is directly by default giving me the -5 supply power port. If I want to change it, uh, here you can see the toolbar on the center top. Here are multiple options available. So the last fourth one, sorry, here you can see the ground symbol. You can just right click over there and this many power ports option are available on the LT. So currently we will just place the ground. So yeah, I'll just select the ground port. Uh, I want to connect it over here, but its orientation is not matching. So I can just rotate by clicking the space button and just place it over here. And let's connect the another ground. So when you have selected the component, and if you want to basically don't want to use, you can directly press the escape button to go to the normal mouse, or you can directly click the right button. So whenever I press escape, the component is gone. And this is the normal mouse which I use. Let's make sure remaining connections. So that's much was for the ground. Let's change it. Yeah. The next thing is plus minus 15 volts supply. You can just go to the port section, click on right click, and place the VCC port. Yes. VCC. We can always change its designator value or the name. So, for example, instead of VCC, I want to give it plus 15 volts. So, how can you do that? You can just double click on the component. So the properties panel on your left will appear, and here are multiple options which we can change for the selected component. So for the power port, I can change its name. So let's change it to plus 15 volts. Then, yeah, and after that we can change its style. So this is currently bar tab. bar type. So I can just select the if I want to change its symbol, I can just go to circle or whatever signal which I want, and also go to the right now. Just let's keep it to the bar type itself. The next one is this power connector that is minus 15 volts. Then there is another of 3.3 volts. So let's go to VCC and place it over here. Again, double click and make it plus. So, here all the schematic, all the components which we need to have is already done. You can see the schematic and yeah, so all the components are done. Yeah, the value of this capacitor. So if you want to see the details of the component which you have already placed in the schematic sheet, you can just double click, and here all the properties, details, and everything will be appearing. So let's change its value again. 4.7. So looks like here the capacitor is shorted by mistake. Okay. Yeah. So right now you can see there is a red colored bar which is displayed on top of each and every component. What does this red color bar means? So this red color bar indicates that there is some error. So in our case, the error, what is the error? So how do we see how do we come to know what error is? So you can just go to the project panel on the left hand side and just right click on the project name. And here you can see the option validate PCB project and your project name. So whenever you validate it, it will display a message bar on the right hand side of your screen. Here multiple error and messages are being displayed. So what are those messages? So here at first you can see that it is uh, being displayed by multiple colors. So there is yellow colored, then there are orange colored. So what are these orange colors? So whenever I hover my mouse on the top of this orange color, it will display error, which means that this is uh, these are the basically errors. What are error? Whenever I select and go to this detail section, it says that the duplicate component designators. So as you can see over here, all my capacitors, resistors, components are basically not named, or basically they are not annotated. So there are two methods by which we can annotate the schematic. First is manually, obvious. You can just go to the component, basically double click on the component, and you can change its value. For example, C1. Then if I want to change the value of this designator of registers, I can just go R1. But for this kind of schematic, it is okay. But whenever your schematic is too big, the creating of annotation manually would be very time consuming. So what this Altium has done is Altium has basically given you option to annote all the schematic. So how you can do that? So you can just go to the tools section on the toolbar, and then there is option of annotation, and there is the first option, annotate schematics. You can just click. So this type of window will appear onto your screen. So here you can see which sheet is to be annotated. So there is the sheet which we are working on is sheet 1. So just select the sheet which you want to annotate. Then these are all the components which are currently not annotated. And see C1 which we have done, but the rest of the components are not annotated properly. So how we can annotate those schematics automatically? You can just update the change list. So it says that 11 changes has been made. So there were 11 components whose annotation was pending. So okay. The next is we have to accept all those annotations. So you can see right now all these composite components which were not designated or annotated previously is now annotated in this manner. So you just have to accept all those changes. So you can see the capacitor, registers, and the IC is being annotated. So you will have to just validate all the changes which it has done. So what does this validation means is that whenever the components are annotated automatically, it will basically see all the components and check whether all the components are annotated properly or not. And are there any components whose annotation is uh, basically same. So the two components cannot have actually same annotation. So in that case, it will show error. But right now, there are no errors. So we can execute all the changes which it has done automatically. And yeah, that's it. You can just close both windows. And right now you can see that all the components which were not annotated previously are annotated. For example, R3, R5, and here R7, C5, then the ICU1, and everything. So that's how you can annotate your schematic automatically. Now coming to the here we have just drawn the schematic, but there is no input from which the input can come to our. Basically, there is no input for our IC, and there is also not any output. So what we can do is we can basically add a connector uh, which will be giving input to this two uh, input to the IC, and its output will be again going back to the connector. So let's just add the connector. The connector which I'll be needing is basically 3-pin connector, two for inputs and one for outputs. I'll directly search over here, 3-pin connector. So these many are the connectors which are available on the Altium cloud. So you can just see the which you can just select whichever connector you want to use. For example, if you want to use the Phoenix connector, you can directly search 3-pin Phoenix connector. So these are the Phoenix connector. So this one is the Phoenix connector, which you all might have seen multiple times. So let's use the same connector. Again, same. We can just select the component and drag and drop on the schematic. And to rotate, you will just have to select the component and just hit the space bar. So now let's keep its orientation in this manner only. Now, for example, I have to make the connection from R3, which is over here, to pin number 1 of connector. So there are basically, again, two options. First is what we can do is connect it via wire like this on connector. Yeah. And again, we can do this by wire. But in this, the basically this way doesn't connects to pin to input to the connector, but it doesn't look good actually. So what we can do is just delete these wires, and there are a thing which is called as net. So what does the net do? I'll show you how we can draw the net. Once again, you can go to the place, and here you can see the net level option. You can select that and add the net as well. Or what you can do is go to the port option. Sorry, you can see over here that the place wire option is there. You can, if you just right click, there are multiple options. So right now we will be using net label. So just click on the net and you can just place it over here and just make the desired connection. So basically this will be connected to net. Uh, so you can, I'll just place another net as well. So yeah, I can also rename this net. So just a double click, I can change its name as well. So let's give it input positive, and another one is input negative. So these two are the nets which are connected. So if I want to connect this pin number 3 or R3 or the net in plus to the connector, I can directly copy this net and place it over here and just make the connection. That's it. So in this manner also you can connect two component without giving the physical wires on in the schematic. With this, what are the advantages of this? So you can save lots of space, and your schematic will also look good. So right now, while placing the net, after placing the net, the this in plus is physically not connected in the schematic sheet, but in the layout, you will see a track which is directly connected to the pin number 1 of the port. In the same manner, you can also do for the output. So just select the net over here and just rename it output and just the net of same name is over here and just make the physical connection. So, yeah. So the basically the nets with the same name are connected in directly without any wires being placed on the schematic file. So yeah, so in this way we have completed our schematic. If you want to make it more beautiful and more readable, we can always do some like labeling, and also you can go here on the text, select the text, and just give, you can give it the name whatever name you want. So I'll just give it the name. Uh, you can just give it sensing surface. You can directly change its properties. Just double click. If I want it somewhat bigger, if I want to change its color to red, let's keep it blue itself. And I want it bold. Yeah, that's the sensing circuit. If I want to give it outline, I we can do that as well. So here you can see the symbol. Just right click on that and whatever shape you want. So let's get a rectangular shape. Yeah. And just double click and just remove the fill color and keep it transparent. But the line border of the rectangle is like very too small, so you can just double click on that, go to properties once again, and change its border size. So let's keep it medium size. So yeah, in this way we have completed the schematic. But that yeah, we have not annotated the port. So what you can do is again you can do manually annotation if you want, but if not, you can just go to the tools annotation and annote schematic once again. So we have to annote the scheme. Just select the sheet which we want to annote and just update changes. So it says one changes were made. So previously we have annotated all the schematic, just when the connector one was pending. So right now the connector has been annotated. Okay. Then don't accept the change list. So here you can see the connector J is modified to J1. Let's just validate the changes and execute it. Here you can see the J1, the connector has been annotated. Now validate. So previous when we have validated our schematic, saying multiple errors. So now let's check are the errors still being displayed or not. I'll just clear all the messages and once again right click and validate the PCB project. So that I can see on the messages there are no errors. These are just warnings. You can ignore the warnings and not necessarily you can ignore the warnings all the time. You have to go to the warnings as well when you have to create the schematic. But most of the things are basically unnecessary. For example, the one which it says is off grid. Off grid means the component is not basically matching the settings of your current schematic. So what are basically the grid settings? Here on the bottom left, you can see grid. So and grid, it is giving me 1 mm. So what does it mean? That I can change the component wires with the minimum navigation of 1 mm. So here you can see the component which I'm pressing is moving for 1 mm. the each one box is of 1 mm. If I want to change the grid setting, you can do easily by shortcut by pressing G. Here right now you can see that it changes from 1 mm to 2.5 mm. If I hit again G, it changes from 2.5 mm to 5 mm. So right now again it is going back. It is back to 1 mm. So the component which we have placed is not matching the grid setting. That's the meaning of that message. But you can ignore those messages. And at last we can see it says compilation successful, no errors found, which means that your schematic has basically no issues or no problems. Uh, yeah, the one thing. There are some warnings which says there is floating object 3.3 volts, and which means that 3.3 volt is not connected basically. So yeah, how we can verify is it connected or not? So so this there is one ground. This ground over here. If I just pick and move it, the wire also moves along with it, which means that this ground component is connected to the wire. But in case of this 3.3 volt, when I select and move this component, there is no wire. Sure. So which means that the 3.3 volt supply is being kept floating. So we'll have to just we cannot ignore that warning. So we have to make physical connection, and after making the physical connection, if we move, the wire also moves along with it, which means that it is now connected to R2. You can see what are the other warnings. So there are no other warnings. So yeah, the compilation is successful. So that's this is how we can draw our complete schematic. After that, you can also rename your sheet. Just right click and rename. So this let's give it test schematic. So here we have renamed it. So this was just a basic circuit of a basic sensing circuit of by using the op amp. So the actual circuit which will be using won't be this simple. There will be multiple components, multiple connections you will have to make, and the schematic won't be just this small. It will be like very big. So just while making the schematic, keep this in mind that it should be neat and clean. The one looking at your schematic must understand what is that schematic, what that circuit does. So as you can see, and separate the schematics. As you can see over here, I have separated this schematic with the box and also given it title. I'll also show you the one more schematic which I have done. So if you want to open the previously existing projects, you can go to the file, then open project, and then directly route to the direct. You can route to, you can yes select the projects which are available on your workspace. Or if you don't want to use the project on your workspace, you can go to the local project and navigate to the project which you want to display. So this is the one of the schematic. So we can see all the schematic in this case is like properly connected to each other. They are properly labeled. They are separated from each other like this. So that it is easier for anyone other than you who is reading the schematic. It will be very useful for them to keep the schematic neat and clean and simple and properly labeled. So let's just close this project for now. So yeah, that was for the schematic. Uh, yeah, the one thing is of libraries. So if you are using any of the component which are not available on the manufacturer part search or the Altium cloud, so what do we do in that case? So for example, so this is the audio amplifier circuit, so which is using LF351. So let's just search LF351. Is it available on the Altium cloud or not? LF351. So it sorry, not LF. It is so you can see that all the model symbol has been crossed, which means that Altium does not have the model of the required component. So what we can do in that case? So there are multiple websites. You can just browse through your browser, and just you can easily you can search the component that was LF351 and its Altium footprint. You can just search it online. So there are multiple websites which provide the ECAD model as well as the Altium footprint and its 3D model. So you can just direct to those websites. So the website which I will prefer you to use are like two websites. The first one is Ultra, named as Ultra Librarian. I'll show you here. Just type Ultra Librarian. Yep, the first one. So this is its website. You can just go to the website and directly search the component whose model you want. So our component is LF351 and search. So these many models are basically available on the Ultra Library website. So this website is completely free, and you can, if you want, you can have your registered account. If you don't want to register, that's completely fine. You can just go and select whichever model you want. So, for example, let's look into this model. So yeah, this is how its symbol will look like, and this is its footprint, and this is its 3D model. So it is showing its package is deep. If you want SMD package component, you can just navigate back and select the package. So yeah, this one is also again deep package. So it's another one. So, so yeah, here you can see the package is SMD package. The component is SMD package. So yeah, if I want to use this package, you can easily download it. You can just click download now. So it will ask you in which format do you need to download the component of the library. So we are using Altium. You can just go to Altium and the file which you want is Altium designer file. The library given by Ultra Librarian can be used for any other PCB designing software as like a KiCad or Cadence. You can also directly download the library for those software as well. So right now we are using Altium, so I'll just select the Altium designer one, and I also want its 3D model. So I'll also select the 3D model which is supported by Altium. So the extension for the 3D model which is supported by Altium is step. I'll also select this step one, and for the downloading, I'll just install again once again. So all these websites are basically free to use. So you can just log in and download the footprint which you want. Now. So it will start downloading. So there is one more site which I prefer to use that is called as SnapEDA. You can easily search SnapEDA. So this website also has LTM footprints and all, which you can download for free. You will just have to log in, and it is free to use. Let's search LF351. And yeah, this many footprints are basically available on the website as well. So right now our download has been completed. So after downloading the library file, I'll just show you how do we import it on the LTM file. So at first you will have to extract that file into some folder. So that's the file downloaded was zip file, so we'll have to extract it obviously. So yeah, here you can see this is the extracted file. So if you go inside it and Altium Designer, you can see the multiple files which are present over here. So, these are basically extensions which are used by Altium software to import files from like externally import files. So if I want to import another new library, what we can do is go to the file section, and there is option called run script. You just click on the run script. Here you will have to direct to the location where you have downloaded your library. So it was then here you will have to select the so here just one file is being displayed, which is LM351 LF351 import file, and its extension is Altium script project. You will have to select that file. Once you select that file, you will have to select it once again over here and then click OK. It will once again ask the location of that file. So yeah, this is the text file which we have downloaded along with the library. And after that, you can easily start import. It will say no, but you can ignore that. And after that, you can see on the left-hand side in the project panel that library has been imported. So what if you have to look at the library? You can directly click on the library. You can see this is how its schematic will look like. And you can also preview its 3D model. So if you select it, it says there is no preview available. So there might be some problem. So due to which it is not preview, showing me the preview. So this is actually Altium bug, I would say. For to make the preview available, you just have to go to the PCB library file. In that PCB library, here there are multiple files. You can just select one of them. So this is the file which we have downloaded. All the files are basically same. There are no different. And then just apply and save this file. After saving this, you can again direct back to project panel and go back to schematic. So right now it is giving me preview. So that is actually a bug from Altium side itself. So how we can solve that bug is basically go to the PCB library file and then navigate to PCB library section on the bottom left and just select the footprint and click apply. That's it. After that, when we go back to our .sch file, we select the model, it will display its footprint as well. So that's how you can import. Sorry, the main step is missing. After doing all this, you just have to right click on the library file name and select the option which says compile integrated library, which will basically integrate library and add to our component phases. It will just ask to save once again. And yeah, okay. So this library has been added to my components. So how do we access that file? So if I have to add the imported library file into our schematic, you can go to the components and here in the all section, you will just have to select the library which you have imported. So right now, which we have imported library is this LF351. Just select that, and we can just normally drop that schematic. So yeah, here you can see we have imported the library and which we are using it here over here. So that's how you can import the library. There is also another thing by which we can create the library. So you can go under the file section new, and there is the option called new library. But we will do it in the later stage. Right now, let's keep it simple and just like for your knowledge, we can also create the library. Right now, let's just stick to it, and that's how here we have completed our uh, drawing of schematic. Yeah. So until now, does anyone have any problems? They can ask me in the comment section about the schematic or anything which you have done right now in the between.
No, when you are given label, like for example, in place at two places, how do you
Correct.
know that is there any show command just to
Yes,
highlight?
there is. We can just select the wire and it says the physical name and net name. Here we can see the physical name is in plus. And once we go over here and select the same the wire which we are connected to the port one. It also says the physical name in plus. So whenever the net and the net name as well is in plus. So whenever the net name of two components is same, it connects those two components.
Okay. Otherwise, it won't show in a bright color that
No,
no, not
no,
that.
it won't show. It won't show.
Okay. Okay. Understood.
We can verify this as well when we import it in the PCB file. So yes, sir, we can show the PCB file as well, like importing, or should we stop here?
No, no. Today we don't be working on the layout part. Now,
Okay,
what you should tell them is about uh,
like
other
installation process and all.
whatever is schematic related thing only today we will highlight.
Hmm.
Whatever is
Okay, okay,
whatever maximum possible. Second is
okay,
in the second half, just we will share the some list of resources and videos.
okay,
Let
okay,
them
okay,
see on their own from online videos, resources,
okay,
whatever they want to study material. And end of the day by 5 o'clock, we will give them some schematic diagrams as a assignment, or they can also come up with their own after studying. They should also come up with their own designs. So tomorrow we will take the
correct.
presentations. Based on that
Okay,
presentations, we will give them certificate of participation. That is a day one
okay,
completion. Once we are satisfied with the schematic, then we will conduct the workshop on the layout part with some expert talks. So today, as much as possible, we'll try to focus only schematic diagram only.
schematic part.
Right.
Okay, okay.
Yeah.
So the what I have done over is just the basic schematic file. The usual schematic file won't be just consisting of a single page schematic. There is also a thing which is called as multi-page schematic. The project which I have shown you earlier. I'll just open it once again. So yeah, so this schematic on the left hand side, you can see there are like multiple sheets which I have imported. So it is nothing but called as multi-page schematic. So why do we do the multi-page schematic? If you draw the schematic, if there are like the schematics are actually very large in size when we go for actual PCB designing and all of actual components. So it is basically not possible to draw. It is possible to draw actually on the single sheet if we change its dimension, but it is not actually advised. So in that case, what we do is we make the schematic in multi-page manner. So here all the five sheets which you can see on the left hand side are of A4 size. You can see the size of sheet from the properties section. It is of A4 size, and I have separated all the sheets according to its application. For example, the first sheet we can see is main control board. Then the next one is for sensing. So this sensing sheet actually consists all the sensing circuits which I am using. The next part is communication. So this communication sheet consists of all the part which is used for communication. Then the next sheet is for ADC. So like in this way, you can segregate your schematic into multiple pages according to the circuit which is in that schematic. You can separate for communication, sensing, ADCs, for other sections, and then main. So in this way, you can create the multi-page schematic. So how do we import multiple pages in our normal schematic? So here, previously, what we have done to import the schematic file is just we have right-click it and then add new to project. To add multiple pages in the schematic, we have to follow the same procedure. Just right-click over there, then add new to project and add schematic. So right now you can see the second sheet is being added onto the schematic. So right now this library part is done, so I'll just close it. For closing it, you can you just make sure that your file is saved. You can do that by Control S, and then right click over there and just close project. Select the option for close project. It will basically close that project. yeah, in this way you can add the multiple sheet. Now, how to make the connection when in the multiple sheets? So, for example, in this case, we have added net label like in plus, in minus, and here in plus, in minus for the connection. But when we make the connection in multiple sheets or multi-page sheet, the net label is not valid. The net label is actually valid when the connection is being made on the same page. For example, this in plus is going to the in this connector, which is on the same page. So it will make the connection. But if there is some net, if there is net with the same name, let us copy this and make it here. And let's just add some registers. Let's say 10K. Yeah. Yeah. So here there is the net with the same name in plus, and on the another page there is also a net named in plus. But in the actual PCB, what will happen? It will in plus in different and this in plus as a different entity, which will give the error. So you will just have to make sure what components are used for what thing. So net label is actually used to make the connection within the same page of the sheet. So what if we have to make the connection between multiple sheets? For example, I have to make some connection from sheet 2 to this sheet 1. How do I do that? So for that, there is the option known as ports or offsheet connector. You can go to the place section and here you can see the port. So you can add the ports. So what does this port do is basically it connects signal from one sheet to the another sheet, from the first sheet to the second sheet. So if I give the name to this port as in plus, and remove this net, just make the connection. Yeah, just rearrange it for now. And let's give another port, this as a minus. And remove this net. Let's rearrange it a bit. So what I've used over here is the port. So what does port do? This port are basically used to make the connection in between multiple pages. For example, from this sheet 1 to sheet 2. If I create the same port with the same name, for example, and let's give it the same name. Is in. So here you can see it provides me the drop-down menu. By which I can select which port I have named. So I just select the in plus. So whenever I select the in plus, this text appear. This is nothing but the cross reference. So what does this cross reference means? That this port in plus is connected to the test schematic file name and connector number 5B. So if I go back to this, so this one is the connector which it has connected to. How we can verify here on the cross reference, we can see sheet number 1 2B, which means that when we go to sheet number 1, this connector is being connected to, sorry, this port is connected to the port over which is over here. In the same way, if I want to connect in plus named port to some other thing, here you can see the in minus is connected. It is given with another cross reference, which says that it is connected to the test schematic 5B. which is over here. So in this way, you can connect the multiple ports for the connection in between the multiple pages of the schematic. Uh, there are also some other thing other than port known as off-sheet connector. The purpose of off-sheet connector is also the same. To basically, as the name suggests, off-sheet connector. It is basically used to connect multiple ports or multiple things in between the multiple sheets. So it also works in the same fashion as the port. You can just connect the port over here. If you want to change its name, you can change. Let's say, give it again in double click. Give it the name in class, and you can just place the same offsheet connector here. So whenever I connect it, it will display the cross reference. So what there is one thing. What happens when there are multiple cross reference available? What, for example, if in this case you can see there are multiple ports which I have used. Here are multiple ports. Here are multiple offsheet connectors. If we display this cross reference for each and every sheet, the schematic sheet will look so much occupied. We can hide this cross reference as well. For that, you just have to double click over here and just click this I symbol. It will basically hide the offset connector. In the same way, you can do for the. Sorry, it basically hide the cross reference, not the offset connector. Sorry. And you can follow the same process over here. Just hide. So right now you have seen like I am doing this manually. There is also if there are multiple ports and I have to hide its cross reference. So for that, what we can do is there is another process, which is by using the selection filter. So in the top toolbar, you can see there are multiple options. One of them is for selection filter. If I click the selection filter, here are the multiple things which I can select, and which all are active. So if I click all off, it won't allow me to select anything which is present on the schematic. As you can see, I'm dragging my mouse, clicking the components. It nothing is happening. Same with this. If I go and keep it all off, it won't allow me to select anything. Not even the text, not even any of the components. So what does the selection filter do? It allows you to select only selected components which you want to edit. For example, right now I have turned everything off. If I want only components to be selected, I can just select the component. So this C2. So you can see I can move the component C2. But if I go to this is the text. If I go and drag this text, it won't allow me to change anything regarding the text. So why is it so? So it is because the selection filter has basically enabled the editing for the text file, and I can just change the symbols. So I just component. It won't allow me to change the ports as well. You can see over here. Whenever I select the port and try to change anything, it won't happen. That is the one basically use of a port. If I want basically text to be selected and nothing else, I can just select the text, and nothing will happen to my original schematic. Only text which I have made is basically editable right now. So this also helps. This selection filter also helps very much when there are like so many things on the schematic. Now to hide the cross reference, you can just select the other components and ports. So you can see the cross reference is basically available for this port and just for offset connector, which comes under another section. So I have just selected those two, and if I press Control A, it will highlight all those components which are being selected. Now, if I want to hide the cross reference for each and every one, I can just right click and go to the properties section, and here cross reference is available. So if the cross reference, you can see all the ports and offset connectors cross reference is being hidden. So instead of doing individually, you can do that combine combining it as well. After that, you can just go back and turn on all the parameters. So that was how you can hide the cross reference. Oh, I don't want the second sheet in this as well. If you want to start normal editing, you can just turn on all the offsheet, all the components. Yeah, that's it. So that's pretty much for, what you will need to draw schematic, basically simple schematic as well as some advanced schematic by using multi-page schematic method, and which you can do using the connectors as I mentioned. So yeah, does anyone have any doubts within that? Yeah. Okay, so I guess no one is having any doubts. So yeah, the last thing which I'll show right now is how do we save the schematic on our workspace. So initially we have created this project offline, or basically we can say locally on the PC. So if I want to save this project on my workspace and access anywhere else, so what I can do is just right click on the so this project panel available on the left hand side. You can just right click over there, and there is an option called as make project available online. So right now it is, you can see here is that symbol highlighted in red, which means that it has been modified, but locally, not on the workspace. So to make it available online and to make the uh, this schematic accessible, you can just make click this make project available online, and it says the project should be saved. So yes, let's continue. It says it asks for project name and any description which you want to give. So let's keep the project name same and add the description like this is just project schematic. Okay. Mm. So yeah, that's it. After the once that is done, it will basically make your project available on the workspace. So how you can verify that? The one thing is the initial, you can see now the test project has come under the workspace title Sardar Patel Institute of Technology. So this this project is now available on the SPIT workspace. So to verify it, we can go to the workspace. You can just click on the workspace of which you are part of, and then just click the browser option. It will open the workspace, and under the projects section, you can see this project, the project which we have done right now, test project 02, is available on the workspace. That's how you can upload the schematic and any PCB project on the workspace. And once you have modified your workspace, you can just push the changes which you have done by just a single click. I'll show you how you can do that. Let's just modify our circuit little more. Let's just let's, instead of this output, let's place one pole. Let's give it name output. So, oh yeah. So right now I modified our schematic little more. So after modification, you can see here the option has been popped up, which allows me to save to server with just one click. So whenever I click save to server, uh, it asks me what changes should be saved on server. So we have modified the schematic file, that is test schematic. I just allow that file, and okay, that's it. The changes which we made over here has been basically pushed on the workspace. So you can easily view on the workspace as well. If I open the project, So I'll just need to refresh it. And just open the project, and right now you can see the port is added over here. So the once you have the access of workspace, you can easily store and download the changes which you have made from that in the file. For downloading the changed schematic, you can just open the file and select the downloads on the top right. If not, you can just navigate back and just click then download. Okay, so you can download the back. So you'll just have to yeah, go and select the file, and then you can download it from here. So it will be downloaded with the changes which you have done previously. So yeah, that's how you can save your project to the workspace. Yeah, that's it pretty much for today actually, for the schematic. So anyone has any doubt, just let me know.
Sir, am I audible?
Yes, you
Sir, so across multiple sheets, when you are making
are.
references, so how is it implemented on a single PCB?
In the single PCB, the schematic which we are drawing is just for our reference. It is in the multiple pages. But while importing all the changes in the PCB file, it is just connected on the single PCB itself. You will get more clarification when we go to the PCB part actually. When we import the changes from the schematic and go to the PCB part, you will get actually more clarification over there. It just consider it as a single schematic only.
Okay, sir. Thank you.
Okay. Anyone else?
What are the output files we can create? One is PDF,
Okay.
image, what are, yeah.
Okay. Yeah. So I'll show you. There are like multiple output files. For example, let's start with the BOM. So whenever you have made the first thing which you will need is BOM. So there is the Altium has provided the easiest way by which you can create a BOM. So what you can do is go to the reports, and there is a option itself which says BOM, bills of material. So whenever you click that, it just creates the Excel file, Excel sheet, which consists of all the comment, description, all the designator, all the footprint, all the references, and all the quantities uh, of the components which we have used. So and we can just export it in the desired format. So it exports in the mostly Excel format. So you can just save it. Okay. And to view that file, the file is actually stored on the out file. So you'll have to navigate over there. So let's go over there. What's the path? It's POM. You can also preview the sheet. This is how it will look like. It just give all the comment, description, designator, footprint, and references and quantity of the components which we have used, and we can just save that file. So it's on the desktop. So this one is our project file. So here on the outputs, here we can see that the BOM is created. So that's the one thing which we can export the output job file. Next is we can basically create the PDF by default, which is by going to the file, and there is option called as Smart PDF. You can just click, and you can just follow the default settings. Yeah, if you want, you can make some changes as well. For example, if you want to modify the output file name, I'll just keep it same for right now. It We can select if there is multiple pages, you can select what are the pages which you want to be on the PDF file. Right now there is just a single, it is just a single page schematic, so you can just select it will by default it just select one. Then it asks me whether I want the BOM as a part of a schematic file or not. So if I just click on, if I don't want it, I can just uncheck. Right now, let's say I want the BOM along with the schematic file. I'll just click on the check. Here are some additional settings which it allows me to do. So there are like color settings. Either you want grayscale, monochrome, or color. Let's keep it to color. Here are the marker, the things which you want to include in your schematic PDF or not. So let's just keep it by default right now. Here you can see it says the following things are to be needed in the PDF or not. For example, pins, labels. We actually need all those things. So let's keep it enabled. And next. And yeah, so this is the path where your file is stored. You can just finish it. And to access the file again, you can go to the output job file. Here you can see the PDF is generated. So this is what the circuit which you have made previously, and this is its BOM. This is the one thing. Then there are again multiple things which I will show you. So this is how you can do it individually. But if you want everything in the one place, so what you can do is just right click and add new to project, and in that add new to project, you can create a output job file. Just add the output job file. So so this output job file is created. So all the options which we can see over here are the output job files which we can create within the same for the same project. For previously we have created BOM and schematic PDF individually, but you can directly create easily. You can easily create everything over here. For that, you will just have to. You can just folder structure. You have to create the folder structure. Select the folder structure from here. If I want assembly output, it is not allowing me because I haven't made the PCB layout and routing, as well as I haven't created the Gerber files and it. So it is not allowing me for that. It is allowing me to do the schematic print. It is nothing but the PDF which we have generated previously. I'll just show you the another way how we can do that. We'll just have to create the out job file, then select the folder structure over here, and just select the document output section. In that we can add the schematic print. So which schematic do we have to add? So these two are basically same. It's add the physical. You can just change the name of the schematic as well. So it 01. And then this is the file folder name which we have created. Right now, to add the schematic, you have to right click over there and go to the configure option. Here you can just refresh and preview how our PDF will look like. It's currently gray. So if I want in the color form, you can select the color and refresh. Yeah, that's it. And okay. And right now the PDF file has been created. No, actually no. Yeah, actually yeah. 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 So this is the print job which we have created. You will have to change. So right now it is showing the printer which I have connected. So instead of that, I want some another format. Let's say I want it in the PDF format. just select the PDF. Okay, and just enable to which path do you want to add this PDF. So right now I have enabled this file, which is 01 file. So which means that the PDF which we are creating will be stored in the 01 file. After that, can print it. So for file name, which will be 01. And yeah, that's it. That's how we can also create the schematic. So there are multiple files. Again, once we complete the PCB component placement and routing, it will allow us to print all the other thing. For example, for the fabrication purpose, we can also create the Gerber files once we finish the component placement and routing. Gerber files, drill drawing files, and all. The drill files, the masking files, and all. For assembly output, it also create the multiple test reports, assembly drawings, and all. For the BOM, you can go to the report section and add the BOM. Previously, we have individually added the BOM. Here, you can directly add BOM to the same output job file. And there are many more. You can also export the 3D file. Uh, so once the component placement and routing is done, you can view the schematic, view your layout in the 3D view. And that 3D view can also be stored in the form of PDF. Yeah, over here. Here you can see there are multiple PCB 3D print option, but it is not enabled because we haven't created the PCB layout and all. So once we create that, all those options will be enabled, and we will be able to print all those files, all those output files. There is also a separate tutorial video. I'll just show you. So this is the reference resources which I created. Sir will be sharing this with you. So what it consists is that it has multiple playlists from the beginner layer, then intermediate to advanced and advanced level playlist. And there are also some additional resources. For example, this is the video for installation. This specific video I have added separately, which basically tells how do we export all the output files and what kind of output files can be exported from the Altium. So this is the separate individual video which basically tells everything. And there is also a Altium designing PC design course link which I have given over here. So what does this course is basically offered by Altium itself, and it is free for the students and all. You can freely enroll into the course and complete the course, and you will also receive a certification from the Altium side after completing the course successfully. So you can also learn many more things from this designing course as well. So, yeah, that's it.
Yeah, Anshul, one last question. The way you said generating the output files, so can we
Correct.
also have some videos based on how to generate the output files for Eagle software from, and
Uh,
how to import the Eagle files into
from
Altium,
Altium. Okay.
and
Yes, we
also
can.
importing multiple saved files into one single workspace?
Okay. Yes, I can. Basically, this video shows everything about output files, how we can create output files, how we can store it on the single space and all. And the regarding importing PCBs from one file, one software like from Eagle to Altium, we can do it in the next lecture as well. Or I'll just share the video link with in the same document.
All right. So have we done for the day?
Yes, we are.
Anything left? Yeah. Should we conclude, Anshul?
Yes, sir.
All right. So let's thank Anshul. He took a lot of pains, particularly for me, to create these contents and recording. Though he's very busy, his ongoing projects are going on. But for the benefit of our students community,